Okay, now we can take a look at slightly more complicated equations, and let's start with example 3. So here we have 7x plus 12 equals 5x, and we have to solve the equation for x. What makes this equation different from the previous examples is that we have an x term on the left and the right side of the equation. And that, of course, means that we can't just do our normal steps to isolate x. For example, if we were to subtract 12 from both sides, we would have 7x equals 5x minus 12. And if we divided both sides of the equation by 7, we would have x equals 5x minus 12 over 7. Well, that doesn't tell us what x equals because we still have an x term on the other side. So we can't be in the mode of let's isolate x until we make sure that our x's are just on one side of the equation. Could be on the left side, could be on the right side. So we have two choices. Choice one is we could get rid of the 5x that's on the right side, which would mean that we subtract 5x from both sides, right? We could say 7x plus 12 minus 5x equals 5x minus 5x, right? We could subtract the 5x from both sides. 7x minus 5x is 2x plus 12. 5x minus 5x is 0, so we have 2x plus 12 equals 0. And this is just like examples 1 and 2. We could solve the equation from here. The other way to do it, starting with the same problem, 7x plus 12 equals 5x, we could get rid of the 7x. So we could say 7x plus 12 minus 7x equals 5x minus 7x. 7x and negative 7x is 0. It cancel each other. That's why we were subtracting 7x. We are left with 12 equals 5x minus 7x is negative 2x. And again, this is not very different from the equations we solved before. We can also solve it. And so just to finish the problem, on the left side, if we got to 2x plus 12 equals 0, we could subtract 12 from both sides. Right, 0 minus 12 and 2x plus 12 minus 12. Canceling the 12s, giving us 2x equals 0 minus 12 is negative 12. And then we divide both sides of the equation by 2 because x is multiplied by 2. We want to undo that. And so we're going to divide the negative 12 by 2. And we're left with, I'll write the answer over here, x equals negative 12 divided by 2 is negative 6. Which, by the way, is what you would get on the right side if you got to the point 12 equals negative 2x and then divide by negative 2, again, to undo what's happening to x. So 12 divided by negative 2 equals negative 2x divided by negative 2. And so x equals 12 divided by negative 2 is negative 6. Notice that you, of course, will get the same correct answer because both ways are correct. It's really up to you. Do you want to get rid of the 7x and leave all your x's on the right? Or do you want to get rid of the 5x and leave all your x's on the left? A lot of people, from what I have seen, like to get rid of the 5x because it looks nice when you clear the whole right side. I personally like to get rid of the 7x here because I'm trying to isolate x, so I want x's to end up by themselves, right? Like I did here. I have 12 equals negative 2x. My x's are by themselves, as opposed to, in this case, I don't really win anything from the right side of the equation being 0, but here I have to get rid of the 12 and 2. It's slightly more work. Again, leads you to the same correct answer, but takes one step longer. Okay, let's take a look at another example. We have 5x minus 14 equals 3x plus 4. Again, the thing that we should notice is we are solving for x, and we have x's on both sides of the equation. And again, we have a choice. Do we subtract 3x from both sides and not have x's on the right, or subtract the 5x from both sides and not have any x's on the left? I'm going to choose to subtract the 3x because I know 5 minus 3 is a positive number. 3 minus 5 would have been a negative number. And you know, I'm a positive person. I like to be positive. Again, both ways would get you to the correct answer. It's just, I think, one way is slightly more pleasant. So I'm going to subtract subtract 3x from the left and right side of the equation. 5x minus 3x is 2x minus 14 equals the 3x, and the 3x cancels, leaving us with a 4. And again, now we are in very familiar territory. We are trying to isolate x. So first we will undo the subtraction of the 14 by adding 14 to both sides. So we're going to add 14 to the left side, and we are going to add 14 to the right side, right? We add the same thing to both sides. That leaves us with 2x equals 4 and 14 is 18. And now, since x is being multiplied by 2, we are going to divide both sides of the equation by 2 to undo the multiplication. And our answer is x equals 18 divided by 2 is 9. And so there you go. When you see x's on both sides, just subtract the x term from either, to get rid of either the one on the right or the one on the left. And from there, the problem should look familiar. Just like in all the other equations that we solved, you can always plug your answer in to make sure it's correct. For example, in example 3, if x is negative 6, we can just plug that into x. And 7 times negative 6 is negative 42 plus 12. 5 times negative 6 is negative 30. And of course, negative 42 plus 12 does equal negative 30. So our equation in problem 3 was correct. Similarly, in example 4, if we plug 9 into x, 5 times 9 is 45 minus 14 equals 3 times 9 is 27 plus 4. And in both cases, 45 minus 14 is 31. 27 plus 4 is 31. Again, looks like we have the correct solution.